Okay, so we are getting started with the Elasticsearch, Kibana, Fleet Server and Windows Server setup. I will be installing a Elastic agent on the Windows Server and setting up the Elasticsearch and Kibana. The Fleet Server will host the Fleet Server that will be responsible for managing the agents. And as discussed on the class, we'll be using VirtualBox as our virtualization tool. And the virtualization tool, in the virtualization tool, we have some specific requirements regarding the networking mode. The networking mode will be set to breached on the Elasticsearch and Kibana server, plus the Fleet server will also be on the breached networking mode. The Windows server will also be using the breached networking mode. We have assigned the IP addresses as an example, so I'd be working with them. The first server that I have already set up is the Elasticsearch plus Kibana server. This is the server that we're looking at and I'm following the document from the Elasticsearch setup. So we have installed latest JDK using sudo install apt install openjdk 11 jdky. Then we'll be setting up the environment variable using vi, and we'll also be sourcing the Java home and also installing Elasticsearch. Once we have installed Elasticsearch, we'd get these details of the Elasticsearch setup. We'd also be editing the JVM options to make sure we only consume a little bit of memory, and then starting Elasticsearch. After that, we'll try to log in as Elastic user on Elasticsearch. Then we'll be installing Kibana on the same server. I'll start by looking into the IP addresses. The IP address for this particular host system where we will be installing Elasticsearch and Kibana is 192.168.1.12. So I would open up another terminal. Then I would do something like Ubuntu 1.12. Now I'm into the system. I'd be running the commands that we have on the Elasticsearch setup. So first, let's go here and then try to install openjdk. Since I already have installed openjdk, it shouldn't show me any further notices regarding the installation. But yeah, I would proceed forward with setting up the GPG keys for the installation. Since it's already there, I'd proceed with the no, but you can try it out if you have not already. Installing Elasticsearch now. Let's copy this thing, open up tty, then do something like sudo, and yeah, Elasticsearch is now being installed. Let's wait up some time for this installation to complete. It will take some time depending upon the speed of the internet, but hopefully it completes soon. Seeing a very good speed, so let's hope it completes soon. At the end of this installation, we need to take care of this particular portion of the installation that would be spit out as the part of the installation. So we would copy them and would keep it somewhere safe so that we could use the commands or use the credentials that were generated, the password that will be generated as a part of this installation. It's still taking up around 30 seconds to install this. It's around 655 megabytes. It's pretty downloading at a pretty much decent rate. So let's hope it completes soon. We'll wait up once this is done. This only needs to be done on the Elasticsearch instance. The other instances, we don't need to do anything regarding this. So it's a one-time task. Let's see it completes soon. Yes. So it's unpacking the Elasticsearch binary and then installing. One problem that I faced with the low memory systems is that when we don't adjust the Elasticsearch memory, it's going to consume a lot of memory in the Elasticsearch portion, and then it's going to it's going to freeze the entire system. So I would recommend the very first thing before starting off Elasticsearch to adjust the memory in JVM options. So it's on the etc Elasticsearch JVM options. You need to edit this file, change the JVM options to 1 GB memory. That way, if it's a very low memory system, probably if you are trying to do this or replicate this lab on a system which has very less memory, then that's the way to go. So it has given us the security auto configuration information. This is what we need to copy from here to the end of this section. We would copy this and then keep it somewhere safe so that we could use it again. The next thing that we would do is I would switch into the root user and then start editing the JVM options on this particular file. The only reason that I'm doing this is I'm also constrained in memory, and I just want to try this out as a lab, so I'm making sure I don't overwhelm this system with the memory, so my system really can work with 1 GB of memory. It's just for demonstration purpose, so it should do it. So we have set it up. Now we can fire up Elasticsearch. So let's do system ctl restart Elasticsearch. Since our Elasticsearch has now started and we're seeing a green status on our Elasticsearch server, what we would do is we would now try to use the credentials that we have already copied and then try to see if this particular login is successful. I'll copy the command and for the password, I'll copy the password that we had. Okay, and then I'll paste the password. So let's give it a shot. Yes, since Elasticsearch is working, half of our work seems to be done now. We are good to go with the Kibana setup now. So I would start installing Kibana with apt install Kibana -y. Let's see if it's complete. So the next step for us would be the creation of the enrollment token, which we would do using the command that we have there. So we'd be using the Elasticsearch create enrollment token command, and we would make a small bit of change on the Elasticsearch on the Kibana configuration to make sure that our Kibana configuration works properly. Since the Kibana configuration is complete, we'll now use this particular command to generate an enrollment token for Kibana. Okay, we have the enrollment token for Kibana as well. We'd edit the etc Kibana and then kibana.yaml file. Make sure that the server.host is set to 0000 rather than localhost. Okay, 0000, and we'll save this file wq start Kibana server. Let's try to start the Kibana server and try if we can access it from our IP address. So it says it's running. We'll try to open it up 192.168.1.12 and it's going to be 5601. And yes, we have this Kibana installation. We'll now paste the enrollment token. Yes, let's copy the token and try to paste it here for the enrollment. Copy the code from the server or run Kibana verification code to retrieve it. There's nothing as such on the yes. We have the Kibana verification code that we generated using the command sudo user share Kibana bin Kibana verification code. This is going to be 643696. So let's try this. 643696, and now our Elasticsearch configuration along with Kibana seems to be complete now. Let's give it some time to complete and the Kibana dashboard to load. We'll now move on to setting up the fleet server. We'll be needing a new Ubuntu instance for this. Like we talked in the class, we'd use the clone to server to complete this. So let's give it some time and we'll start. Since it took some time to complete this setup, we are now back into the dashboard for Elasticsearch, and the username for this would be Elastic, and then the password would be the password that we used when we were setting up Elasticsearch into the Kibana dashboard. We'd configure the fleet server and other integrations from our side. So what we would do now for now is we'd just try to explore on my own, and on the left side what we would do regarding the fleet server setup is we'd go to fleet, and then on the fleet side we would try to add fleet server. For this we'd have to specify a name of the fleet server and the URL that we would be using, since we are still to set up the. Now we have reached to the Elasticsearch UI, the Kibana, and then we'll try to set up the fleet server. So going on to the fleet server, we would add fleet server. For the policy name, I'd use the fleet server policy, and for the host, I'd specify HTTPS 192.168.1.21 8220 and we'll generate a policy. Once this policy is generated, it will throw a bunch of code that we need to modify a bit for my ARM based installation, and then we can continue with it. If you have a Windows based installation in which the CPU architecture is AMD, which is x86-64, you can directly proceed with pasting the command, but my CPU architecture is a bit different, so I would try to modify this command first, and then I'll try to paste this command here. So let me modify this command. What I would do is in all x86 I'd replace them with ARM. That way this commands can be reused again. So we would go to the console now for the fleet server, and we would paste this command. The places where I made the changes is on the, if you look into the original commands, there are x86 64 all over the places. I made a change so that I would change the architecture to Linux ARM 64. So let's run it. It will download the Elastic installer, and then once the installer is downloaded, it would ask you for the permission to set up to install this application. It's nearly 400 megabytes in size, so it's a bit heavy file, but it would, let's hope it downloads soon. And also on the connection confirmation, once the agent reports back to the fleets to the Kibana, then we would see the connection has been established, and we can proceed further with gathering the details about the installation. Only difference that would be a bit different in my setup is I would have to change the architecture for almost every host, since I'm using ARM based system. For you, it would be you could just copy and paste the command and it should work out of the box. We have nearly 200 gigabytes of data downloaded, and let's hope it completes soon. We're probably 90 megabytes away from downloading the complete installer. This architecture would be helpful for me, since I have a ARM based laptop, and then the instances that I have set up are also ARM based. So there's a little bit of change that I have to do for my purposes only. You can directly copy and paste. Since it has downloaded, it is inflating the file, extracting the archive, copying the data. It is prompting me for the password to install into the agent, and once I hit continue for the confirmation as well, it would copy the files. It would report the status back to the agent, and we can also see the confirmation connection that we are seeing from this is also changing. This portion would also change in a bit, and we have completed the fleet server setup. So we'd continue with the agent installation now. So agents are basically the small binaries that we would generally install on individual hosts to collect data from them. And firstly, we would create a policy for Linux, and then we would try to gather matrix from a Linux host. I already have a Linux host running, so I would try to gather a matrix from this particular Ubuntu agent. So I try to boot it up. So it's already running, but probably in the background. I'll try to restart this system once again. So it run, and the process remains the same. You'd have to copy this binary, you'd have to copy this link and paste it on the system. That way it would complete the enrollment process. And one thing I'd like to point out is that on this last command where you'd use the enrollment token, just make sure that you add the dash dash insecure flag as well, as mentioned in the gist. It would make sure that the TLS based handshake for establishing SSL connection goes through the since we are using a certificate that's not supported by or issued by any particular cloud provider, then we would be using the insecure flag. And also for me, I'd have to modify this command as well for this. If you feel kind of lost, then feel free to go to agents, go to Linux, and that way you would be, or just move back, On the agents, probably not here. On the here, you could just go and add agent here. You'd get the same token here, same set of command here. I'd copy this command. Looks like my VM has booted up. This is the fleet server, and this is going to be the Ubuntu agent. I would log into the system and check and see if this has a public IP address of the private IP address of 192.168.1.14. I'll try to SSH into the system. Let's do 14. So remove this, and then I'll try to log in into this. Yes, I'm now logged in into the system. I'd copy this command. I'd adapt to make sure that this feeds the architecture for my system. I'd just replace the x86 part with ARM. That way a compatible agent for my system will be installed. And also I'll make sure I would add the test as insecure flag at the end of the enrollment code to make sure that we don't have issues with the handshakes. So I would go into the system, copy and paste. So yes, also the binaries are very big in size, around 400 megabytes, so it will take some time, but hopefully it would be a bit less than the earlier one. Yeah, it's downloading at a very rapid speed, probably cached on the ASP side. And also, while this is downloading, we could see the fleet server has reported us back. The fleet server is looking healthy, and it has reported us with the matrix, the system integrations. We are collecting logs from the logs. Matrices, journal D is not available. We'll look into that in a bit. The logs are being collected, and on the fleet server side, we can also take a look into the input. If we try to look into the matrix, then it would generally show the uptime for the fleet server, which we just enrolled, and I just made sure that this system is getting just started, so it would give us an overview of the matrix or matrix data that we are here. We're looking into this, and also let's go and check back the installation. It's asking me for the password. Now the Elastic Agent installation is successful, and we can also see that incoming data is also confirmed. We can start with setting up other details as well. We can see we have two agents that are connected to the fleet server. One of them is the fleet server itself, and another of them is the Ubuntu agent. It will start populating the details in a bit. For now, we can see some logs are being collected, and you can also see some of the matrix related details that are being forwarded. So we can see the CPU related usage, and also see matrices regarding this particular host. One more thing that we will try to do is we'll try to boot up a Windows system as well, and then try installing the agent on the Windows system as well. So on my UTM, I have Windows system as well. I'll try to run this system, and we will try to see if we can install this agent, install a Windows agent on this system. So for this, we would use the same method. We would go to fleet, and we would just add another agent. For that, we'd have to create a policy, and on the policy side, we'd use another agent policy. The name of the policy is going to be Windows, and we'd create an agent policy. That way we could keep the policies related to Windows systems and Ubuntu systems separate. So we would go here and then add an agent. So the enrollment token is already there. For the Windows system, we have a PowerShell script that generally gives us the details about the installer. I would Once we are into the Windows system, we can just copy the archive details and then try pasting it into the PowerShell. My Windows system has just booted up. I'm trying to start the PowerShell, and then I'll paste this command on the PowerShell. It would download the agent and would use the elastic install command to install the elastic agent. We can also view the elastic agent on the agents that have connected to the uh, fleet server. So let the system boot and the PowerShell becomes usable. Since I had to do a bit of workaround for downloading this content that we need to paste on the Windows agent, I finally managed to copy this, and I'd be copying and pasting this. So I'd copy this and paste it on the Windows system. It would download the agent, take some time, and then it will register back to the incoming to the system. So that way we'd have a very complete setup where we have Windows agent, Linux agents, and the fleet server, all of them working in coordination to send this data. Once this is complete, we would see the reports flowing on into this system while this is getting complete. Let's go back into the logs that are being received and try to take a look into this. We can take a look into the dashboard systems. We get a bit of errors. Some tuning need to be done here, but we can technically see the login events. We have the login sources for Windows, and the logs are yet to arrive, but we can see the SSH login attempts for the Linux systems that are being collected, and also we can see the sudo commands that were run on the systems. I tried to edit the etc host, did a couple of sudos, SSH logins, new users and groups. So syslog related logs can be seen on the agent. Let's check back if the installation has completed. So it's asking me whether I want to run this agent as a service. I clicked on yes, and then it will copy all of the files, make sure that we can fetch data from this particular Windows installation. Also, we can go back here and the fleet server nodes addition part. On the fleet server, on the agent policies, Windows agent policies, and add an agent. When this will complete, it will start collecting data or sending data, and we can already see some changes that are there. So it's waiting for enrollment, and also we can successfully see that this agent has enrolled. It will send some data, and yes, we have seen some data being fed into the system. Let's check to see, yes, this has successfully completed, and we would see the data arriving into the system in a while. So it would take a bit of a time to get it get the logs there. It will not directly send sysmon related logs. So if you want to enable sysmon related logging, then you'd have to tune something here. Just so to enable sysmon support on the ALK agent, we'd go into the Windows agent, and then we'd go to the agent itself. On the agent policies, we'll go to select the system, we'll add integration, and for Windows we'll add Windows based integrations. We'll add it here. If you take a look into the logs that we could be collecting from, is that we'll be collecting the PowerShell related logs, PowerShell operational logs, and sysmon operational logs that will be created by sysmon here. So we can save and continue, and this will update the agent with the latest changes, and it will also fetch logs from sysmon if the logs that are if sysmon is enabled on your system and sysmon is generating operational logs, then these logs will also be enabled into your system. We can take a look into the dashboard now regarding the new logs that are flowing into the system. Let's see, we have what we have already here on SSH login items. We see these. We can try to simulate some events and then probably see also. Let's go to discover and then see the logs flowing into the system. So a lot of new logs are flowing into the system. We can take a look into the new logs that are being ingested into the system. I try to run some ESQL query and then make sure that we get the right logs from the right analytics from the SIEM data.